The fundamental purpose of any smart energy meter is to accurately and precisely monitor and meter energy consumption. Smart energy meters are installed in residential and commercial sectors. The accurate and precise metering is managed and controlled by the e-meter system on chip. These are various smart e-meter SoCs from TI, which have sufficient power to meter the energy consumption, manage the metering algorithms, and have integrated on-board RTC and display. All these energy meter SoCs also have the on-board communication ports, which can be configured into UART functionality, serial peripheral interface functionality, and I2C functionality. Different LPRF radios and communication modules are connected over these UARTs and SPI to give the end connectivity of the data from the smart emitter to the utility server. This is the latest smart emitter system on chip IC introduced from Texas Instruments. This has a 128 KB of flash, 8 KB of RAM on board, has a CRC16 module, which stands for Cyclic Redundancy Check 16. Very important and useful in case of any kind of communication. Also has a 32-bit hardware multiplier, which gives you not only the efficient utilization of real-time processing, but also gives you a quick calculation power. Apart from that, it has several IOs which can be configured into input and output direction and can be configured to take external world interrupts. As it is a system on chip, it has integrated real-time clock module, which can be temperature compensated. Also has a liquid crystal display LCD display driver, which can drive up to 320 segments of LCD. The precise and accurate metering in the smart e-meter SoC is ensured by its highly linear sigma delta ADCs. These sigma delta ADCs have a resolution of 24-bit. There are total number of 3 channels for these sigma delta ADCs. Apart from sigma delta ADCs, this SoC also has a 6-channel SAR ADC 10. This ADC has a 10-bit of resolution. Two of the very interesting blocks introduced by TI in this SoCs are the port mapping controller and the auxiliary power management module. The port mapping controller gives you a great freedom of designing the hardware as per your wish. That is, you can map the functionality of any of the modules in the SoC to any of the IOs as per your convenience in the PCB design. In the auxiliary power management module, you have the provision to manage 3 number of auxiliary power supplies, meaning that not only you have the VCC to power up the SoCs, but apart from that, you can have 3 sources of power, that is 3 auxiliary supplies, auxiliary VCC 1, auxiliary VCC 2, auxiliary VCC 3. The power management module, that is the auxiliary power management module, manages all these supplies on its own. The only thing which you are required to do is to configure this auxiliary power management module in the initialization of the code or the initialization of the application. This SoC also has a very unique block called as unified clock system. In the unified clock system, there are total 3 number of clocks. 1 SM clock, 2nd MC clock, 3rd A clock. The biggest advantage of this unified clock system is you can source any of the peripherals modules on this e-meter SoC through any of the clocks. That is, you can configure your ADC to source from SM clock, M clock or A clock. You can configure at the same time your timer module to source from A clock, M clock or SM clock. At the end of the day, the unified clock system gives you a great advantage to configure your application or design your application for a highly power optimized energy meter by sourcing different peripherals of the e-meter SoCs by different clocks to ultimately cut down or optimize on the power consumption. From the connectivity perspective, this smart e-meter SoCs has huge number of UARTs and SPI modules on board. It has total number of 3 UARTs and 2 SPIs, which can be configured or used for external world connectivity. The external world connectivity involves the wide area network connection or the home area network connection. Just because you have 3 number of UARTs, you can have 3 multiple modems at the same time on the single board. You can use one of the UARTs for 2.4 GHz LPRF radio connectivity. You can use the other UART for sub 1 GHz LPRF radio connectivity, and at the same time you can use the third UART for the power line communication module. This emitter SoC can work up to 25 MHz, which gives you a total available power of 25 MIPS. Because of this huge fundamental MIPS power available on board, you can not only do the metering calculation, but also can do the total harmonic distortion calculation and the fundamental power calculation. This SoC has a 24-bit sigma delta ADC on board. This is a highly linear ADC which gives you a capability to design a single product to address all the accuracy class needs. By all the accuracy class needs, I mean you can design the same board for class 0.5 accuracy and class 1 accuracy.